Hi, we're going to do derivatives day 2. So the most popular use of a derivative, or probably not the most popular, but one use of a derivative, is to find the slope of the tangent line. So if you're looking for the slope of a line tangent to a curve, if you remember from Regents geometry, what a tangent line is, it's a line that hits any curve, a circle, a parabola, any curve at all, at exactly one point. Okay, so to find the slope of the tangent line, the first step is to find the first derivative, dy dx, and then evaluate the first derivative at the value of x that you're given, and that will give you the slope of the tangent line. So for example number 1, we want to find the slope of the line tangent to the graph. F of x is equal to x squared plus 3x at an x value of 1. So f of x is equal to x squared plus 3x, and we have to find the slope of the line tangent to this curve, this is parabola, at an x value of 1. The way you do that, step 1 is you find the first derivative of the function. So f prime of x, the first derivative, is equal to 2x plus 3. And this 2x plus 3, the first derivative, is the equation for finding the slope, and you just plug your x value into that. So the slope of the line tangent to this parabola at an x value of 1, I would evaluate f prime of 1. That's going to be 2 times 1 plus 3. So the slope of the parabola x squared plus 3x at an x value of 1 of the tangent line is 2 plus 3, the slope is 5. And then it says to graph the parabola and the line tangent to it at x equals 1. So if you have my notes open, which I truly hope that you do, I have an XY table of values in my notes. So I went to my graphing calculator and into my y equals screen, and I put x squared plus 3x. I've got a table of values. So this includes the point 1, 4 is part of the parabola, and then the parabola looks like this, and it looks like this. So here is, and again, look at the notes that I've got for you on Schoology. That's the parabola x squared plus 3x. And we want to graph the line that's tangent to this curve at an x value of 1. So here's our x value of 1, and the slope of that line is 5. If you remember back from your Algebra 1 classes, you could always write your slope as a fraction 5 over 1. Because it's positive, you would go up 5 and to the right 1 to graph this line. So you would start here, you'd go up 5 to the right 1, or you could go down 5 to the left 1. And this line would be the line that's tangent to that parabola at an x value of 1. Okay, so Roman numeral number 2 in your notes. To write the equation of the tangent line, first thing you need to do is find the slope of the tangent line using the first derivative. Then if you need to, find a y value at a given x point, if you need to do that, if it's not given, and then use the point slope formula, y minus y1 is equal to m times x minus x1 to write the equation of the line. So, example number 2 in your notes for today, you are given the equation f of x is equal to x cubed minus 2x squared plus 1. And we want to write the equation of the line that's tangent to this function at the point 2, 5. So we are using the point 2, 5. All right, so step 1 is you take the first derivative of the function, f prime of x is equal to 3x squared minus 4x. Remember, the derivative of a constant is 0. If I plug in my x value of the point to the first derivative, it's going to give me the slope of the line tangent to this curve at this xy ordered pair. So my slope will be f prime of the x value of 2. So it's going to be 3 times 2 squared minus 4 times 2, 12 minus 8. So the slope of the line tangent to that curve at this xy ordered pair is 4. Or if you're graphing that tangent line, it would be 4 over 1. Now we have to write the equation of the line tangent to this cubic function at this point. So you go to your point slope formula. Y minus y1 is equal to m times x minus x1. The y value of our point is 5, y minus 5. The slope is 4. X minus the x value of our point is 2. Distribute y minus 5 is equal to 4x minus 8. Add 5, y is equal to 4x minus 3. Now, if you are graphing the tangent line, you would want to keep it in this form, which is your slope-intercept form. Our slope is 4 over 1, our y-intercept is negative 3. But if you're giving me a line for an answer after you've done this, you always have to put it in general form. And remember, general form, your x has to come first, and it has to be positive, then your y, then your constant set equal to 0. So what I'm going to do is I'm going to move my y over, and I would be left with 0 is equal to 4x minus y minus 3. This last line right here is your general form, and this is your slope-intercept form. Okay, now on the back of the notes. For example number 3, write the equation of the tangent to the graph y equals x squared plus 5 that has a slope of 4. So you've got this parabola y is equal to x squared plus 5. So if you kind of think way back to September and October when we were graphing parabolas, this would be just a vertical shift up of your parent function 5 units. And we're going to write the equation to that parabola when there is a slope of 4 for our tangent line. So our original function, f of x, or y, is equal to x squared plus 5. Our first derivative, f prime of x, y prime do I dx, is equal to 2x. Now, when you find the first derivative of function, this is the equation for your slope. If we had the x value, we would plug the x value into this, and this would give us our slope. But this time we're given the slope, and we're told that the slope of the line tangent to this curve is 4, so we have to find our x value. At what x value would the tangent line have a slope of 4? So I'm going to plug the 4 into here, because I know that's the slope. And when I divide, the point on that curve where the tangent line has a slope of 4 has an x value of 2. Now I have to go back and find my corresponding y value for that point. So here's my function. I know that the x value is 2, where the tangent line has a slope of 4. So I'm going to plug this number back into the original function to come up with my y value for that xy ordered pair. Here my original function is y is equal to x squared plus 5. I'm going to plug 2 in for x. 2 squared plus 5. My y value is going to be a positive 9. So the xy ordered pair 2, 5 on this parabola would have a tangent line to that parabola that has a slope equal to 4. And now I have to write the equation of that tangent line. So I've got my slope was 4, that was given in the question. I have my xy ordered pair, and now I can use my point slope formula again and write the equation of the line tangent to this parabola where the slope of the tangent line equals 4. So now I'm going back to my y minus y1, my point slope formula is equal to m times x minus x1. Y minus the y value is 5. The slope was given, it's 4, x minus 2. Distribute y minus 5 is equal to 4x minus 8. Add the 5. I just made a mistake. Just realized I made a mistake. The y value is 9. I'm fixing my mistake. We found the y value to be a 9. So the ordered pair is 2, 9. So now this has to be a 9, a 9. I'm going to add 9 to get this into slope-intercept form. Y is equal to 4x. When I add the 9, I get plus 1. So this is your slope-intercept form. If you were graphing it, it would have a slope of 4, or 4 over 1, and a y-intercept of 1. But general form, your x term has to come first. It has to be positive. So 0 is equal to 4x minus y plus 1. That's the equation of the tangent line to this parabola that has a slope of 4. Okay, now the last example, oh my goodness, this is why you really should open up my notes. Do you see all the yellow highlighting and like numbered 1 through step, 5? This has a lot of steps, but I think you're going to understand it. I'm not going to draw the graph when I work through the equation here, but when you guys open up my filled-in notes, I think you should do the graph and really pay attention to what's going on with this question. So the tangent to the curve, y equals x minus 2 squared. So here's our function, y equals x minus 2 squared. That is a parabola that has a horizontal shift right 2 units from the origin, from our parent function. At the point 4, 4, so the tangent to this, at the point 4, 4, so this is the x value where we want our tangent to, we want to find the equation of the tangent line of this curve where x is equal to 4. Crosses the x value at P and the y-axis at Q. So your x-intercept is P, your x-intercept is P, your y-intercept is Q. And in the end, what we have to do is we have to find the distance or the length of the line segment P to Q. So we're going to have to go back to that distance formula that you learned back in Regents geometry, the big square root symbol, x2 minus x1 squared plus y2 minus y1 squared. All right, so let's work through this step by step. The first thing that we're going to do is we're going to find the first derivative of this function. Okay, so step 1, we're finding the first derivative. Y prime. Well, first let me expand the function. X minus 2 squared is x squared minus 4x plus 4. Okay, that's your original function. Your first derivative, y prime, is equal to 2x minus 4. Remember that the derivative of a constant is 0. So right now, I found the first derivative. Now that I've found the first derivative, I want the slope of the line that is tangent to this parabola at this xy ordered pair. So I'm going to take this x value of 4, plug it into the first derivative, and that's going to give me my slope. So my slope is going to be f prime of that x value of 4. So it'll be 2 times 4 minus 4, 8 minus 4. The slope of the tangent line to this parabola at this xy ordered pair is a slope of 4. There's a lot of 4's in this question. Okay, so that's the first thing that we needed to do. We took the first derivative, we plugged in the x value, we found the slope. Now I have to find the equation of the tangent line. That's going to be step 2. So to find the equation of this, the tangent line, I need my point slope formula. Y minus y1 is equal to m times x minus x1. Y minus 4, the y value of the point is 4, the slope is 4, the x value of the point is also 4. It's just a coincidence that there's all 4's in this question. Y minus 4 is equal to 4x minus 16. Y is equal to 4x minus 12. So this equation right here is the equation of the line that's tangent to this parabola at this xy ordered pair. So that's what we've done so far. Now I have to find my P and my Q. This is review again. To find P, which is our x-intercept, so step 3, I'm going to find the coordinates of P. And the way you find an x-intercept is you let y equal 0. So if I go to this equation and I let y equal 0, 0 is equal to 4x minus 12, 4x equals 12, x is equal to 3. So the x-intercept is going to be 3, 0. Now I have to find the coordinates of Q, my y-intercept. So here's step 4. I'm going to find Q. Q is the y-intercept. To find that, you let x equal 0. I'm plugging it into the equation of the tangent line. I'm going to let x equal 0, so y is equal to 4 times 0 minus 12. Y equals negative 12. Okay, so the coordinates of the y-intercept of the tangent line to this parabola at this xy ordered pair has coordinates of 0, negative 12. We're almost done. We have to just do step 5. Step 5 is find the length of P to Q. And that goes, as I said before, way back to Regents geometry, and you need your distance formula. So we're going to find the length of line segment PQ. The distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Plug in your x and your y values. Okay, we are using this point P. We're using this point Q. So for my x values, it's going to be 3 minus 0 squared plus my y value, 0 minus a negative 12 squared. So it'll be 0 plus 12 squared. The distance of P to Q, 3 minus 0 is 3 squared is 9. Plus 12 squared is 144. So the distance of P to Q is the square root of 153. So that is what answers the question. So there was a lot of steps there, but I don't think it was really hard. Just a quick review. To find the slope of a line tangent to any curve, step 1, find the first derivative, and then plug in the x value of the point into the first derivative, and that will give you the slope of the tangent line. If you have to write the equation of the tangent line, you might have to go back and find the y value by plugging the x value into the original function. That would give you your y value, and then go to your point slope formula. Okay guys, I think you can do it.